what is the limit of sequence cosine squared of n divided by 2 to power n as n goes to infinity? To find the limit of this sequence, your sequence an is cosine squared of n divided by 2 to power n, and n goes to infinity. We want to know if this sequence is convergent or it's a divergent sequence. What are we going to do? We're going to apply the method of squeeze theorem or sandwich theorem. Squeeze theorem especially works when you have sine and cosine functions. So since I see cosine squared of n, I know that it's good to use squeeze theorem. Squeeze theorem says, suppose you have function f of x less than equals to function g of x, and function g of x is less than equals to function h of x. It means that you can sandwich or squeeze function g of x between two other functions. But remember that your goal is to find simpler functions. F and h must be simple functions from parent functions. Then squeeze theorem says, hey, as long as the limit of f of x is equal to the limit of g of x, as long as x goes to a, and these two limits are equal to L, then for sure you can conclude that the limit of the middle function is also equals to L. Limit of g of x, as long as x goes to a, is equal to L as well. So this is the beauty of squeeze theorem. Squeeze theorem says, hey, if you have a complicated function, that's fine. Can you squeeze it between two simpler functions? If yes, then as long as the limit on the functions on the left and right are equal, then the limit of the middle function also equal to that limit. But again, since I have cosine squared, I'm going to apply squeeze theorem. Since we have cosine squared, we would like to use squeeze theorem. Because you already know what is the lower bound and upper bound of this function. Cosine squared of n is bounded between 0 and 1. You can also graph this function, or in this case, this sequence. And you can see that this function is bounded between 0 and 1 inclusive, okay? So the range of the function is fixed. You can use the range of that function and basically analyze the behavior of this function using squeeze theorem. Now what? What's the next step? Now divide everything by 2 to n. Divide all terms by 2 to the n. So divide 2 to the n, divide by 2 to the n, divide by 2 to the n. Then what? Now take the limit. Okay, the limit on the left-hand side is 0. The limit on the right-hand side is 1 over 2 to the n as n goes to infinity, which is indeed 0. So far I have 0 on the left, 0 on the right, and I have cosine squared of n divided by 2 to the n bounded between 0 and 0. Cosine squared of n divided by 2 to the n is bounded between 0 and also 0, because limit of 0, no matter what n is, it doesn't depend on n. It is equal to 0. And the limit of 1 over 2 to the n as n goes to infinity also equal to 0. So by squeeze theorem or sandwich theorem, the limit of cosine squared of n divided by 2 to the n as n goes to infinity is equal to 0. But what's the meaning of that? Since the limit is a unique numerical value, so it means that the sequence is convergent. So the takeaway from this question is, as long as you have cosine, sine, or those types of functions, and you can squeeze them between two other simpler functions, use a squeeze theorem. Intuitively, you could say that, hey, since cosine squared of n approaches to a number, right? We don't know what that number is, but we have a number. So here, intuitively, by intuition, if it was a multiple choice question and you wanted to answer it fast, you could say that, hey, cosine squared of n is just a number. I don't know what that number is, but it is a number divided by 2 to the n, and this limit as n goes to infinity is a number divided by infinity, which indeed is equal to 0. So this is a shortcut intuition behind the behavior of cosine and exponential function, and right away you could guess a close value for the limit of this sequence.